Here we have the final problem of exam 3, problem 6. Question 1 is, what is the magnitude and phase of the impedance of this circuit? And so we have our V naught is 10 volts, resistance is 100 ohms, inductance is 10 microhenries, capacitance is 10 microhenries, and the frequency is 1000 hertz. Well, if we pop over to look at our equations, total reactance, which is the magnitude of the impedance, right? Total reactance is given by X total is square root of R squared plus XL minus XC squared. So let's come back over here. Get that stuck in. And we also have that the phase angle, right, is given by this function, by the inverse tangent. Okay. And XL equals 2 pi FL, and XC equals 1 over 2 pi FC. All right? Those are all the equations we need to determine the magnitude and phase of the impedance of the circuit. So let's take a look over in Excel. We've got our capacitance, which I believe was 10 micro farads. Yes. Our inductance, which is also 10 microfarads. We have our resistance, so I'm going to label these C, L, resistance, 100 ohms, voltage, 10 volts, frequency, it was 1000 hertz. Okay. So what is then, this means XC, right, is 1 divided by 2 divided by pi divided by frequency divided by capacitance. Right? XL is equal to 2 times pi times the frequency times the inductance. All right? X total is square root of R squared plus XL minus XC squared. So X total is 101.2487, or just 101.2 ohms. So we'll go back over here and we're just going to put in, this is 101.2 ohms. We're going to go back and we're going to do that again in math mode. 101.2 ohms. All right. Okay. And now phi total. Okay. Phi is the arctangent or atangent of XL minus XC divided by R. Now, one thing to be aware of, this is going to be phi in radians, so phi in degrees equals degrees of that radians value, so minus 9 degrees. Minus 9 degrees. So that gives us the magnitude and the phase of the RLC combination. So what is the magnitude and phase of the current? Well, for part B, we're just going to use our old trusty V equals IR, right? So in this case, that means 10 volts equals I times 101.2 ohms at -9 degrees. And that means that I equals 10 volts divided by 101.2 ohms at an angle or phase -9 degrees. If you remember from phasor math, put another space in here because that's a little crowded. Remember from phasor math, the 1 over the angle is minus the angle is 10 volts divided by 101.2 ohms at a phase of 9 degrees. So 0.1 amps at 9 degrees is the answer to part C, magnitude and phase of the current, right? Current 0.1 amps at 9 degrees. C is what is the resonant frequency. Okay, so the resonant frequency equals 1 over 2 pi, right, square roots of LC. Alright, 1 over 2 pi square roots of LC. If we go over to our equation sheet, you find that right here, resonant frequency 1 over 2 pi square roots of LC. Let's pop over to Excel. We want F naught, right? So F naught is 1 divided by 2 divided by pi divided by square root of L times C. And we get 1.59 times 10 to the minus fourth, are 15.9 kilohertz. 15.9 kilohertz. And that would be the end of problem 6.